Meter builds all their own hardware and software and becomes an IT team's single point of contact for the entire project. Meter designs, deploys, and manages everything needed to get high performance, reliability, and secure connectivity in your entire space. It includes everything from ISP procurement to security, routing, firewall, switching, Wi-Fi, and even cellular, as well as power, DNS, VPN, SD-WAN, and multi-site workflows. Meter's full stack solution covers everything from the very first site survey to ongoing support, giving you a single partner for all your connectivity needs. Thanks to Meter for sponsoring this episode. Please head over to meter.com/heavywireless to book a demo. Welcome back to another episode of Heavy Wireless, part of the Packet Pushers podcast network, and we're here talking about all things wireless. And today I have Rosalie Bibona with me. She works with Extreme. What's your actual title there?
I am a director of product management for wireless.
You make APs. Well, okay, you don't actually make them, you help design them.
Yeah.
A while ago at WPC in Phoenix, you gave a presentation on how the decision process takes to build enterprise class AP. I thought it was brilliant, and you shared some things that I don't think everyone knows about the process that goes into designing enterprise APs. Can you give us just a quick review of why you built that content?
Okay, so strategically, when we at Extreme, we basically come up with concepts when a new technology comes in, whether it's Wi-Fi 6, 6E, 6 gigahertz, or Wi-Fi 7. We as a team, we strategize about how we're going to bring the portfolio out or how we're going to integrate that technology. And the first things we do is look at the market requirements, because each chip technology changes. And when I say changes, it either requires more heat or more power or different features and functions. So the first thing we do is define the market requirements for the segments, and then we'll lay our strategy out for probably 2 years. And the things that we look at is cost of goods. That's the cost of goods of what to make for the product. That includes the cost of manufacturing, delivering the AP, the components. And then we look at internally, we have a burden cost, and the burden costs are all our marketing and sales that have to go on top of it. And then we'll look at the gross margin, and then we'll tier our APs. And tiering just means, think of it as good, better, best. And we'll tier the APs and determine when to bring the access points out. But we pay special attention to those marketing requirements, because if you start looking at the value tier, you won't put the same features in the value tier that you'll put in the premier tier. So a lot of decisions get made up front, and we will lay that foundation over 2 or 3 years for a new technology like Wi-Fi 7, which we're all experiencing now.
Do you start at the top and make the best and then work down towards value, or do you start at value and work your way up?
Typically, we start at premier, and then we go, and I'll be honest, what I chose to do, and our team did, is we chose to go to mid-tier. We did a premier tier, and we're waiting for all the regulatory to happen across the globe on what I call 6 gigahertz and Wi-Fi 7. And then we are going to bring our mid-tier in, and we'll go back and populate our high tier. So we'll bring the high runners out, then we'll bring our mid-tier out, then we'll go back, populate all our other models, and then go back to value tier. So it's very market driven, and a lot of vendors go premier, mid-tier, value, and I do it based on revenue, market share, and different features and functionality.
Is part of that decision based on the adoption curve of who buys right up front?
We all know if we do good, better, best, and you go to best, you're only going to get a certain market segment. So if you bring out your mid-tier along with your high tier at the same time, or pretty close to the same time, you'll get a much larger market share.
And then in the end, is the value tier the good? Do they normally end up selling the most? I mean, it's got probably a broader market.
Yes. So the value tier, you'll ship a lot more volume and I call them to the people that just want to connect. They don't need all the features and functionality that's in the mid tier and the high tier, and you'll ship a lot more volume. But your margins will probably stay the same, but your revenue would be less.
Thanks again to Meter for sponsoring this episode. Please head over to meter.com/heavywireless to book a demo. Meter's the company that delivers a complete networking stack for wired, wireless, and cellular, and a single integrated solution built for performance and scale. Normally, businesses ask their IT group to provide them with fast, secure, high quality, and reliable internet access, as well as all the internet networking, Wi Fi, and cellular needed to cover all of their building and spaces. To accomplish this tall ask, most IT people end up managing a crazy group of multiple vendors, different contracts, and ever changing pricing. Instead, you can have Meter step in and solve all these messy issues with a single solution. Meter builds all their own hardware, all their own software, and it becomes your IT team's single point of contact for your entire project. This is a fundamental change to how things are normally attempted. Working with their partners, Meter designs, deploys, and manages everything needed to get high performance, reliability, and secure connectivity to your entire space. This is a single integrated solution that scales from branch offices to warehouses to large campuses and even data centers, and includes everything from ISP procurement to security, routing, firewall, switching, Wi-Fi, cellular, power, DNS, VPN, SD-WAN, as well as multi-site workflows. Meter's full stack solution covers everything from your first site survey to your ongoing support, giving you a single partner for all your connectivity needs. Every building has a power meter and a water meter. Meter wants to make the same true for your internetworking and your internet. Please head over now to meter.com/heavy wireless and book your own demo. One of the things that you probably said multiple times during your presentation, and it made sense, was power is king. What did you mean by that?
Power is king. And it's very important. And if you looked over the generations of technology when we build products, we started with AF and then AT. This is the first time, probably in history, at the premier tier, that if you wanted to turn all the features on, you have to have BT power. That will force everybody in industry that they'd have to rip and replace every single switch to BT, or some people do dual homing to AT ports. So you don't have to have a BT port, but then if you lose one port, you're still at AT power. But you have to be very conscious that not everybody in the industry can run all BT power. Premier companies and premier customers probably could, but not the majority. So to me, the sweet spot is staying in an AT power profile. So we have a whole product line about green efficiency and what we're doing with power. I make a point of it. We were the first ones to come out with the first premier tier to stay in an AT power profile on the 6E products. Now what we do, I even give you power profiles on the premier tier to stay in an AT power profile, because it's very important. And we're probably one of the only vendors that probably pay attention to this a lot, because I can't rip and replace. I'm a switch company too, but I know the customer. Working with the customers every single day, they're like, I need to fit in an AT power profile.
What do you have to give up?
Well, typically you give up the USB port, to give up some power off of the chains. You'll drop the power on the, instead of having a 4+4+4, you could have a 2+4, 3+2. And instead of 18 dBm, you can drop down to like 16 dBm. So you're actually playing what I call, it's not games, but it's controlling the power. Because if you're in a carpeted space, typically you're going to lower your dB anyway. In a carpeted space, something like a warehouse, that's total opposite. You're going to crank your power up because you want to cover more with directional antennas. So you can fit in an AT power profile if you're typically even in a warehouse and you have the premier. The reason you want to stay at the premier is because of the offload. It's not a system on a chip versus a dedicated processor and the offload. So that's what you're really paying for. So that's why I typically love the premier APs, because you can actually do a lot more with them having the offload and not being on a system on a chip.
Could you back up just a little bit and for our audience, describe the difference between a system on a chip and individual components and why that makes a difference?
Yeah, so typically what I call a dedicated, if you have a dedicated processor, a system on a chip is an SoC, and that's how you get your gains in price point. So your premier tier, your better, and then best is separated by, it's definitely by features and price. Since you have a dedicated processor, all the offload happens off of the CPU. So you can run much denser environments. Like in a stadium, In stadiums and arenas, I would only put 4+4+4. So I think that's really important because of the densities that you have in there. The densities and the crowds that you have in a school and an auditorium, I would keep them on the premier tier. And system on a chip, you can get away with putting those in classrooms. You can get away with putting them in, smaller condensed areas where you're not having what I call large densities or, large number of clients.
Is that usually just the difference between the radios on one chip and the CPU's a separate chip, or is there more discrete components other than just those two features?
Yeah, there's other features. It's the Ethernet. The Ethernet's embedded. The PHY's embedded on the system on a chip. It's one whole processor. So you're if something goes bad, you have to replace the SoC, just like on the laptops. All the laptops are all SoCs. Everything's combined. So you'd actually have to replace that whole component. And that's how you get your what I call your delta difference in COGS. A system on a chip is much cheaper than having separate, processors and components.
One of the examples you gave was some just relative, not specific differences between the pricing you have to do on COGS. How much does that actually matter from your standpoint when you have, we'll just say a $10 COGS versus a $20 COGS? How much more features can you get if you doubled your COGS?
Typically, well, it really depends on the market requirements. And like I always steer back to the market requirements. You would keep your same, most companies have different BCOGs for different, what I call ASPs on their products. But I'll give you a feature. I wouldn't put, here, I'll just talk about AP features since we talked to the wireless community. I wouldn't put a dual 6 on the mid tier. You're going to see dual 5, dual 6, dual IoT. That's really in the premier tier. I would not put a dual 6 in the mid tier. Why? You're adding more components and you're adding more filters. So you're making that product more expensive. I would take some features away. If you ever wanted to do your dual 6, go to the premier tier. So everybody's going to say, well, Rosalie, why would I use dual 6? The same reason why you use dual 5. We all said Arrowhive and those guys actually did do dual 5 to begin with. And they do use dual 5 out in industry a lot. So dual 6 is the same concept, but I don't see it coming into play for another couple of years.
Is there's a kind of a natural break in 5 gig between the lower and the upper bands to put some bandpass filters in? Is there any break like that you see in 6 gig?
Oh, yeah. The most important thing when you're developing what I call, and now that we have 6 gig, when you put 5 and 6 gig next to each other, those two radios or frequencies are so close, you have to build in like 80 dBm of isolation between those radios. And that has to do with not just the filters, but also the antennas you put in. So you have, because the two radio frequencies, the upper of the 5 and the lower of the 6 are so close, you have to build in a lot of isolation. So it's very expensive if you do it wrong or pick the wrong filter.
How do you go about picking those kind of components? I mean, is it like you just go to a catalog?
No,
I was
it's not that
joking.
easy because it's new. Um, Keith, is kind of new. Okay, so sometimes the filters aren't there yet because the technology is so new. So you have to wait until the vendors come out with the correct filter. And I know when 6E or 6 gig first started, all the filters weren't there yet, and people were putting filters down that actually took off parts of the 100 and the 1200 megahertz. They took off 160 of 112. And if you launch with, you cannot launch an enterprise AP with the wrong filters because people are paying for that 1200,
Well,
1200
at least they're
megahertz
expecting
spectrum.
it.
Well, yeah.
They're expecting it, and then
You can
they
spin
find
it later, but
But you can, I'm sure in software you can say, oh, you can't use the first 160 megahertz, and software can fix a hardware problem, but I don't think that's going to fix your customers' expectations.
oh, no.
Well, how do you get that information from the marketplace to tell you what goes in those various tiers?
Because when you put out RFIs to the different vendors, most of them will come to, since the consumer APs hit first, When I say the consumers, the ones you buy at Best Buy, and those are consumer APs, they're not an enterprise. Enterprise takes a different class of components that you're putting in there. When you get up into the enterprise, that AP's got to last. You sell the APs for 5 years, and you got a 5-year lifespan after that. So those APs, the mean time to failure, have to be with very good components. So you usually have to wait. Sometimes the filters aren't ready for mass production, so that really binds you on your schedule. So you have to go out to RFI, and the filters are new. A lot of them are new.
You mentioned a term, the mean time between failure. You want to give us an example of what that means and what kind of results do you target in your designs?
Yeah, typically, well, we using quarter. That's just a mathematical model for mean time between failure, but that's used to it benchmarks at a certain degree. Most people use 25C. You use 25C for your in quarter number for temperature, and then you can do what the expected life based on the components. All the components that you put in that access point will determine your mean time to failure. And let me give you an example. If you put a fan in there, a fan is a moving part. It's very bad to put a fan in an access point. You're better off putting cooling technology and you know what I call different kinds of um, passive cooling in the AP um, to keep it alive. So you got to keep that thing alive, because otherwise you're paying in the back end for your RMA, so your return access points, after the mean time between failure. And typically we hit our mean time between failures. All the enterprise vendors do pretty high.
I'm just shocked at it's not in just merely years. I mean, the MTBF numbers most vendors are publishing are way outside their life cycle of what they plan on even supporting.
Yeah, and that's typically because they use an quarter model. And typically, as long as you could feed all that data in, it really has to do with what you run those numbers at temperature-wise. And most of the numbers you read on people's data sheets are at 25C.
So those of us who've worked in Dubai setting outdoor sites might not have the same answers.
That's correct.
Yeah, I've run across that a couple times. It does get warm in some places of the world, and obviously that's another issue. In your MTBF analysis, do you find that there's a time period where if it's going to break, it's going to break, and then if it hasn't broke, it's going to stay for a long time?
It really depends. So remember how I did good, better, and best? When I go to the best, I make sure I use all the top end components, right? And my MTBFs are a lot higher. It typically, when we build enterprise APs, I have to hit a certain requirement, and my minimum is 10 years, but we'll post MTBFs of 20, 25 years or whatever. It's typically has to do with the environment you're in. So if I'm in a warehouse that's really hot all the time, and I'm up at, instead of running at 25C, I'm running at, 50 or 55 in that warehouse all year, your chances of failing are a lot higher than if you're in a carpeted space. So it really depends on your environment. And if you use the right components, and right components comes down to cost. You can't skimp on your components. Everything that inside that AP has to hit a certain temperature. If I'm building an outdoor AP that's IP67, I have to make sure that I put all the components that are down on the board are rated for that, from -40 to 60, with and without solar load. And the same thing if I'm building an AP or a wall unit that's 0 to 40, I got to make sure that it survives in that environment. So every AP is different, and indoor and outdoor is very different.
How about external and not external antennas?
That's such a hot subject with 6 gigahertz and Wi-Fi 7. I knew you were going to ask me that. So,
Well, it's kind of one of those things. It's kind of timely.
it is kind of timely because we finally got the AFC rules, or automatic frequency coordination rules, in the US and Canada. And the only time to have external antennas on 6 gig ports is in the US and Canada if you run with the AFC rules indoor. So now this is the first time, I think they passed it in February, that you can actually put an external antenna on those access points. And most of those access points that you build for DCs or external antennas, you do what I call extended temperature, a -40 to 50 or 55. You use extended temperature components. It's not as, you know, not the same kind of components that you do on an outdoor, but you're in a warehouse that's very cold for freezers or very hot because it's in a warehouse. So now you could do that in the US and Canada, but the rest of the world has integral antennas. And integral is a term that you're going to start hearing a lot outside of the US. In Canada, that means factory installed. If you want to put an external antenna on a 6 gig port outside of US and Canada, they have to be integral, come out of the factory pre-installed. There is one other thing that you could do. It's a power classification called VLP, very low power, but it's only 14 dBm. So I don't think doing 14 dBm in a warehouse is probably usable. We'll see what the market brings. I don't think 14 dBm is usable. I think the VLP was more for tethering.
What are you doing with GPS, specifically for AFC, getting the permission? You have to tell the AFC where you are, every AP. Outdoor APs make sense to have GPS built in. What about indoor APs and AFC that's coming down the pike?
Yeah, so we did two things, and we're just finishing some of that work up. Basically, you have to have anchor APs indoors, and an anchor AP could be a AP either with GPS in it or managed from an AFC node. Like you could do manage from outdoor in. If you had an outdoor node that had GPS, you can manage the indoor node as an anchor. So there's two ways to do it. A lot of the vendors have done dongles, external dongles. We've been approved to run with a dongle. I think that's much harder thing to do when you deploy APs. A dongle, just adding another piece of hardware, is a lot harder. We will use an application. We have an application that we'll use that will trigger. I need at least 3 or 4 APs for my anchor, and then we'll use 802.11mc and AZ. We're doing both depending on what AP it is to find the other APs on the floor. And if it reboots, you can use, you can store all those APs and where they were. Because the FCC is just worried about if you move the network, which after you deploy, the chances of moving the network is
Well, you hope
small.
not. How do you handle differences in elevation?
Two things. We have a pressure sensor. There's pressure sensors in the AP that we use to determine elevation. But you can also do, you can actually put your elevation in. The FCC will let you put the elevation in.
Oh, so that doesn't have to be automatic.
It doesn't have to be automatic. We did it by using a pressure sensor.
I know I'm just asking crazy questions, but they're
Okay.
interesting.
It's new.
On the pressure sensors, does the controller or the control plane at least talk to the other APs on the same floor and figure out like what an average pressure is to tell the difference?
Yes, we store that now too. And we do different things if you put in a high rise in multiple floors. You want to cover your multiple floors instead of doing anchors on each floor. You want to be able to do multiple floors in a high rise.
It's a very complex thing. So how did you get into this in the first place?
I started before 802.11. This will date myself. Before 802.11b was even around, we built networks with military technology. And I thought it was really cool. Like you can actually mesh networks out in the desert. And all that technology was spun off into a company called Mesh Networks. And that's when I started, was way back when, building out. I always built outdoor to indoor. So I've been building it for a long time. So I've made mistakes, corrected them, figured them out along the way. But this is the most complex. 6 gig, it's like being born again. I look at 6 gig, we have more spectrum now than we had for the last X number of years. It's crazy.
By multiples. It's a friend of mine, Joel Crane, put out this spectrum viewer that you can dynamically see the spectrum. And when you zoom all the way out from 0 to 7 gig, it's amazing how much is actually dedicated to unlicensed. Sometimes we think we have these little slivers until you see the big picture. It's like, we got a lot to play with here.
Like being born again. I tell Dave Coleman that all the time. It's like being born again. We're going to see applications you've never even seen before.
Different channel widths. As we move to 6 gig, we've been in the 20 megahertz for 2.4, 20, 40, and sometimes 80s in 5 gig. What do you see happening in the 6 gig range?
I believe the 6 gig will sit somewhere around 80. 80 megahertz. 160, I believe, is a marketing number. 320 is for your home network when you come home with all your kids on cell phones. But in the enterprise, I believe 80 will be the sweet spot for 6 gig.
Well, Rosalie, thanks for your time today, explaining a little bit of how enterprise vendors have the things they have to do to build their APs. If someone wanted to track you down, where would they find you on the internet?
Well, you can definitely get me on LinkedIn. I have a social presence on LinkedIn under Rosalie Babona.
Well, thanks for your time. You've been listening to another episode of Heavy Wireless, part of the Packet Pushers Podcast Network. If you have any comments or ideas, you can go on the website and leave your comments there. Thank you for listening to this episode. We look forward to hearing you in the future.